We're going to look at another example where we're given two functions and then we're asked to find the sum, difference, product, and quotient with them. So here are my two functions. F of x is equal to the square root of x minus 1, and g of x is equal to the square root of 7 minus x. Okay? So finding the domains of each of these functions separately is something that we should do. We should be aware of what our domain restrictions are. Remember, for each of these two different functions, I don't want to end up with anything imaginary. I have radicals here, so imaginary numbers are what I don't want. So in order to find our domain restrictions, I'm going to take x minus 1 and 7 minus x, and I want these to be greater than or equal to 0. Okay, so I set them both greater than or equal to 0, and then I'm just going to solve for x like I normally would. So plus 1 here. I've got x greater than or equal to 1. Here I'm going to subtract 7 from both sides. I end up with negative x is greater than or equal to negative 7. I don't want my x value here to be negative, so I divide both sides by negative 1. And when I do that, remember that my sign here changes direction. So now I'm looking at x as less than or equal to 7. Okay, so just for this first function right here, I can pick any value that's 1 or bigger. And for this function over here, I can pick any x value as long as it is less than or equal to 7. Okay. Remember, this is how we read this. X such that x is greater than or equal to 1. And here it's x such that x is less than or equal to 7. Okay, so first let's find the sum of these functions. So I'm looking for f plus g of x. And remember, that was f of x plus g of x. Okay. So plugging in my two equations here, I have the square root of x plus 1 plus the square root of 7 minus x. Okay. I don't need to do anything for these sets of parentheses. I don't have anything multiplied out front, and I have a plus sign in between them. So I'm fine to just rewrite it without them. Okay. Unfortunately, that's about as much simplifying as we can do. There's no way that we can add these two together and rewrite it in a different form. So right here, we're just going to stop. Okay. So my domain, I still have the same problem. I still need this to be greater than or equal to 0, and I still need this to be greater than or equal to 0. So once again, x plus 1 greater than or equal to 0, and 7 minus x is greater than or equal to 0. So we saw that here we have to have x greater than or equal to positive 1, and here we have to have x less than or equal to 7. Okay, so in order for us to avoid imaginary numbers, any value that we plug in for x has to meet both of these conditions. It has to be greater than or equal to 1, and it has to be less than or equal to 7. So my domain here is x such that 1 is less than or equal to x, which is less than or equal to 7. Okay. When I write it in this form with x in the middle, that tells me that I'm only looking at the numbers in between these two. X is still greater than or equal to 1 if I read from the x, and here x is still less than or equal to 7. Okay, So my domain restrictions kind of travel along with me as I compose these functions together. Let's find the difference. So we're looking for f minus g of x, and that is going to be f of x minus g of x. Okay. So f minus g of x equals f of x, which we said was the square root of x minus 1 minus the square root 7 minus x. Okay. So again, I use parentheses to plug everything in. I don't need them around the first set. And technically, I don't really need them around the second set. When I distribute this negative sign into my set of parentheses, I can only place it in front of my radical. Okay, it doesn't do anything to what's inside of my radical. So I'm looking at the square root of x minus 1 minus the square root of 7 minus x. And once again, that's about as much simplifying as I can do here. I can't combine these in any way. And remember, I still want both of these to avoid being imaginary numbers, so my domain here remains the same. We have x such that x is greater than or equal to 1 and less than or equal to 7. Next, we can find the product. So we're looking for f times g of x. That is going to be f of x times g of x. So I'm looking at the square root of x minus 1 times the square root of 7 minus x. So I still have everything here in parentheses. I don't really have anything to distribute, but each of my sets of parentheses has a square root in it, okay? So I can rewrite this as the square root of x minus 1 times square root 7 minus x. I can take all of it and rewrite it under one set of a radical. Okay? If this was the cubed root and this was the square root, we couldn't have done that. If there was a plus or minus sign in between them, we couldn't have done that. But because it's only multiplication, we can combine my radicals into one here. And then now I can continue to multiply my sets of parentheses here. So this is going to be equal to the square root. X times 7 gives me 7x. X times minus x gives me minus x squared. Negative 1 times 7 gives me negative 7. And negative 1 times negative x gives me plus x. Okay, so I do have two like terms here. I've got the 7x plus this x. So this is equal to negative x squared plus 8x minus 7. And again, my domain restrictions here, I need all of this to be greater than or equal to 0. Once I have that written out, you can see that all I can do here is set each set of parentheses greater than or equal to 0. And we're going to be left with our same results. X is greater than or equal to 1, and x is less than or equal to 7. So once again, my domain remains the same. X such that 1 is less than or equal to x, which is less than or equal to 7. Let's do one more. We have to find the quotient still. I'm going to use a fresh sheet of paper because it gets long. So we want to find the quotient. So that was f divided by g of x, and that's equal to f of x divided by g of x. Okay. So f of x is equal to the square root of x minus 1, and g of x is equal to the square root of 7 minus x. And again, just like I did with the multiplication, I have a square root being divided by a square root. They're both square roots, so I can rewrite it as 1 square root divided by 7 minus x. Okay? Unfortunately, that's about as much simplifying as I can do. The square root of the fraction x minus 1 divided by 7 minus x. Now, when I am looking at my domain, I still want to avoid imaginary numbers in the numerator, and in the denominator, I want to avoid imaginary numbers and 0. So I'm going to take x minus 1, set that greater than or equal to 0 here. I do this to avoid imaginary. So I have x is greater than or equal to positive 1. And my denominator, I have 7 minus x. And on this one, I can't have it equal to 0, so I need it to be strictly greater than 0. So subtracting 7 from both sides, I get negative x is greater than negative 7. Dividing both sides by negative 1, to get rid of that minus sign in front of the x, I get x is strictly less than positive 7. So my domain here is x, such that 1 is less than or equal to x, which is strictly less than 7. Okay, so both of my domain restrictions are still part of my new domain. I just have a little bit of change here because I have to account for the denominator not being 0. And we're done.